This is a lesson on using calculus to find the length of a curve. So let's start from what we know from high school, the Pythagorean Theorem, which will tell us how to find the length of a straight line. So here we have a straight line from x1, y1 to x2, y2. Let's just draw the right triangle. So this point has coordinates x2, y1. The length of this line is y2 minus y1, which I'll just call delta y. And the length of the horizontal line is x2 minus x1, which I'll call delta x. So by the Pythagorean theorem, the length d of the line is the square root of the sum of the squares of the lengths of the sides of the right triangle. So that's the square root of delta x squared plus delta y squared, which if I want, I can write as the square root of delta x squared times 1 plus delta y squared over delta x squared. And that's equal to the square root, I take the delta x out, 1 plus delta y over delta x squared. Now, this is the simple idea behind the formula for the arc length of a curve in calculus. Suppose we have a curve and we want to know how long it is. What do we do? Make it a simpler curve. Suppose the curve just looks like that. So it's part of the graph of a function. So this is y equals f of x. Let's say this is the point A, f of A, and B, f of B. What is the arc length? How do we find this? So I'm going to give a rough sketch of the idea that leads to the formula. But of course, what is required that you know is the formula for the arc length and how to use it. But it's important to understand the idea. So suppose we have a function y equals f of x, and we look at the graph of this function, the curve, from A to B. So let's say this is the x-axis, this is A, this is B. So on the curve, this point has coordinates a comma f of a. This point has coordinates b comma f of b. And what we do is divide this interval up into n pieces. Let's say a is x0, x1, x2, xi minus 1, xi, up to x sub n. That's b. And we look at all these pieces on the curve. And the length of the whole curve is the sum of the lengths of the pieces. So if we focus on just one piece, this is xi minus 1, f of xi minus 1. And this is xi, f of xi. If the interval from xi to xi plus 1 is small, this is not going to differ too much from a straight line. And for the straight line, we just saw what is the length of the line. The length of this line segment is square root of 1 plus f of xi minus f of x sub I minus 1 over xi minus xi minus 1 squared times this delta xi. Delta xi is just the length of the interval from xi minus 1 to xi. And if you remember the mean value theorem, from calculus 1, you have a differentiable function, f of xi minus x of xi minus 1 is going to be the derivative at some point c sub I between these 2 points times delta xi. So the length of the line segment is the square root of this divided by delta xi is just f prime of c sub I squared, delta xi. So the arc length, the length of the whole line, I'll call it S, is approximately the sum of these n line segments you get when you divide the arc up into n pieces. And each of those segments is roughly the square root of 1 plus f prime of c sub I squared, delta xi. So this should look very much like the definition of a derivative if we take the limit as n goes to infinity of these sums This is exactly the integral from a to b of the square root of 1 plus the derivative squared dx. And that is the formula for arc length. So let's do a couple of examples. Now, this is the formula for the arc length of a curve. The curve is given by a function, y equals f of x, and this function has to be differentiable. You have to have a derivative. But of course, the fact that you can write down the formula doesn't mean that you can always compute the integral and solve the equation. Now, of course, if you use a computer algebra program like Maple, you can always get a numerical answer. But to do it by hand can be very hard. But let's just check in the simplest case that this formula gives us what we would expect. So suppose we take a straight line. Y equals mx plus b. And I want to find the length of the line from x1, y1 to x2, y2. So if this is my function f of x, the derivative f prime of x is just m. So the length of this line, s, if we try the formula, this is the integral from x1 to x2, square root of 1 plus the derivative squared dx. Which is the square root of 1 plus m squared, x2 minus x1. Now, that doesn't look like the Pythagorean theorem, but of course, you look at this line, the slope, m, is y2 minus y1 over x2 minus x1. So this is the same thing as the square root of 1 plus y2 minus y1 squared over x2 minus x1 squared times x2 minus x1. And if you do the algebra, if you simplify this, you get exactly the square root of x2 minus x1 squared plus y2 minus y1 squared. So this integral for the formula for arc length does do the minimum we would expect it to do, which is to reproduce the length of a line. Let's do a few more examples. Suppose we want to find the arc length of the graph of the function x cubed over 6 plus 1 over 2x. So if you were to use Maple, for example, we want to find this. So find the arc length on the interval from 1/2 to 2. So it's a curve that looks something like this. This is 1/2. This is 2. What is dy dx? What is the derivative? Well, you differentiate x cubed over 6, you get 3x squared over 6 plus 1/2, and the derivative of 1 over x, or x to the minus 1, is minus x to the minus 2. So this is x squared over 2 minus 1 over 2x squared, or 1/2 x squared minus 1 over x squared. Now, in the arc length formula, we need the square of the derivative. So what is the square of the derivative? It's 1/4, and when you square this, you get x to the 4th minus 2 plus 1 over x to the 4th. So what is the length of the arc? So the arc length, S, is the integral from 1/2 to 2 of the square root of 1 plus this expression squared dx. 1 minus 1/2 is plus 1/2. And what's inside this square root is in fact a perfect square. It's 1/2 x squared plus 1 over x squared squared. Sorry, 1/4 that. So they're integrating the square root of 1/4 x squared plus 1 over x squared squared dx. But this is a perfect square. This is the integral from 1/2 to 2. Square root of 1/4 is 1/2. Square root of this is x squared plus 1 over x squared. That's 1/2. When you differentiate x squared, you get x cubed over 3. When you differentiate x to the minus 2, you get minus x to the minus 1, evaluated from 1/2 to 2. So this is 1/2. When x is 2, it's 8/3 minus 1/2. And when x is 1/2, it's 1 over 24 minus 2. So what is that? Well, we can work out the numbers. This is a half. 8/3 minus 2. This is 16 over 6 minus 3 over 6, 13 over 6. And this is 2 minus 24. This is 47 over 24. Sorry, plus. So if you put this over a common denominator, you get a half. Let's see. 13 times 4 is 52 plus 47. 52 and 47 is 99 over 24. 3 into that goes 33, and into this goes, so you get 33 over 16. So this part is just algebra, just elementary algebra, though you have to do it correctly. But we were able to do the integral for this curious function. Let's do one more. So in the text, this is example 4. We have the function y equals the natural log of the cosine of x. Now, cosine of x is positive from minus pi over 2 to plus pi over 2. And you only can take the log of a positive number. But we want to find the length of this arc from x equals 0 to x equal pi over 4. So this is from 1 to 1 over root 2. So these are positive numbers, and this function is perfectly well defined. By the chain rule, what is dy dx? dy dx is 1 over the cosine of x times the derivative of the cosine, which is minus the sine. So this is minus the tangent of x. So for this curve, the arc length s is the integral from 0 to pi over 4 square root of 1 plus dy dx squared dx. That's the integral from 0 to pi over 4 square root of 1 plus tangent squared x dx. The integral from 0 to pi over 4, 1 plus tangent squared is the secant squared. So the square root of the secant squared is just the integral of secant of x dx. Now, you might not remember what the integral of the secant of x is, but you can look it up if you don't remember. There are tables in the text of all these simple integrals. This is the natural log of the absolute value of secant x plus tangent x. And we're evaluating this from 0 to pi over 4. So this is the log of the secant of pi over 4 plus the tangent of pi over 4 minus the log of secant of 0 plus tangent 0. Now, let's just remember, cosine of pi over 4 is 1 over root 2. The secant is 1 over the cosine. So 1 over root 2 is plus root 2. And the tangent of pi over 4 is 1. So this is the natural log of root 2 plus 1 minus the natural log. Secant of 0 is 1. Tangent of 0, sine over cosine, is 0. Log 1 is 0. So the answer is the natural log of the square root of 2 plus 1. So this is arc length, and it is a very useful formula to know. And there will be a number of homework problems just to practice using the formula. That's it.